Why Music Changes Your Brain Part 1. Welcome back to Army. Have you ever wondered why a single song can instantly bring back memories from many years ago? Why does one melody make you smile, while another can make you cry within seconds? Why do athletes wear headphones before competitions? Students listen to music while studying, and hospitals even use music to help patients recover? Music is everywhere. Every culture in human history has created songs, rhythms, and instruments. Long before humans invented writing, they were already making music. This simple fact has led many scientists to ask an important question. If music is not necessary for survival like food or water, then why has every civilization developed it? Today, Army will explore the fascinating science behind music and discover why your brain responds so powerfully to something as simple as sound. To understand this, we first need to understand what happens when sound enters your ears. Sound is nothing more than vibrations traveling through the air. These vibrations enter your ear canal and strike the eardrum. Tiny bones inside the middle ear amplify these vibrations before sending them to the cochlea, a spiral-shaped organ filled with thousands of microscopic hair cells. These hair cells convert mechanical vibrations into electrical signals. Those signals travel through the auditory nerve until they reach the auditory cortex in the brain. At this point, something extraordinary happens. Your brain does not simply hear sound, it begins to analyze it. Within fractions of a second, different brain regions work together to recognize rhythm, melody, pitch, tempo, harmony, and even emotional meaning. Unlike many daily activities that activate only a few brain regions, music activates almost the entire brain simultaneously. Researchers at Harvard Medical School have described music as one of the most complex activities the human brain can process, because it requires communication between areas responsible for hearing, movement, memory, language, attention, and emotion. Imagine an orchestra. Each musician plays a different instrument, yet together they create one beautiful piece of music. Your brain works in a very similar way. Different regions perform different tasks, but music brings them together into one coordinated performance. One of the first areas to respond is the auditory cortex, where sound is identified. Almost immediately afterward, the limbic system becomes active. The limbic system is often called the emotional center of the brain. It includes structures such as the amygdala and the hippocampus. The amygdala processes emotional reactions, while the hippocampus helps create and retrieve memories. This explains why music often brings back forgotten moments from childhood. Perhaps you hear a song that your parents played many years ago. Suddenly, memories return with incredible detail. You remember the smell of the room, the weather outside, the voices of people around you. Even emotions that seemed forgotten suddenly feel alive again. Scientists call this phenomenon music-evoked autobiographical memory. Research has shown that music is one of the strongest triggers of long-term memory because emotional experiences are stored more deeply than ordinary events. This is why patients living with Alzheimer's disease, who may struggle to recognize family members, can sometimes remember songs they learned decades earlier. In several studies, neurologists found that familiar music could temporarily improve communication, emotional expression, and even social interaction in people with dementia. Music does not cure Alzheimer's disease. However, it can temporarily activate neural pathways that remain surprisingly resilient despite the progression of the illness. Another remarkable effect of music involves dopamine. Earlier in this series, Army discussed dopamine as a chemical related to motivation and reward. Music also activates this same reward system. In 2011, neuroscientists led by Dr. Valerie Salampur at McGill University discovered that listening to enjoyable music causes the brain to release dopamine in the nucleus accumbens, one of the brain's most important reward centers. What surprised researchers even more was that dopamine levels began increasing before listeners reached their favorite part of the song. In other words, your brain experiences pleasure not only when hearing the emotional climax, but also while anticipating it. This anticipation is one reason why humans enjoy listening to the same songs repeatedly. Your brain predicts what comes next, and every correct prediction produces a small feeling of satisfaction. Music, therefore, is not simply entertainment. It is a conversation between prediction and surprise. Every melody creates expectations. Every unexpected chord creates curiosity. Every satisfying resolution rewards the brain. This balance between expectation and surprise may explain why music feels so emotionally powerful across cultures, languages, and generations. Before we continue, let's pause for a moment and think about what we've learned. So far, we've discovered that music is much more than organized sound. From the instant sound waves enter your ears, billions of neurons begin working together to recognize rhythm, melody, and emotion. We've also seen how music activates the brain's reward system, releases dopamine, and connects deeply with memory and emotion in ways that few other experiences can. But this is only the beginning of the story. In the next part, Army will explore how music can actually reshape the structure of your brain, why musicians develop unique neural connections, and how scientists are using music to improve human health. Let's continue.